الله وبركاته. بسم الله الرحمن الرحيم. Today, inshallah, we'll start a new session, and I would call this session the real beginning of data science. All of what we covered so far was just covering some basics or fundamentals, and we will build on top of that, inshallah, starting today's lecture. So the new session is called Testing Hypotheses. Today we'll focus on what we call assessing models. Before we do that, let's go through very quick review of some of the concepts that we covered that we will need this lecture. So the concept of statistic. We'll start with statistical inference. So what is statistical inference? Statistical inference is about making conclusions based on data in random samples. Okay, so we get a sample from the population. We do some analysis to this sample, and based on the analysis, we make decisions. So this is what we call statistical inference. A parameter is a number associated with a population. Okay, and as we mentioned earlier, if I'm talking about the students in the entire university, the average GPA of the students, this is like a parameter of the population. Okay. A statistic is a number calculated from the sample, not from the population, from a sample out of the population. Okay, like if I get a sample of the students in the university, maybe a random sample, okay, and then I compute the GPA, then this is a statistic, okay, not the parameter of the population. And usually we use the statistic to estimate the value of a parameter. That's what we saw before. And also, it is used to test hypotheses, and this is the topic of this session. Now, how do we simulate a statistic? We did that so many times before, right? There is a procedure to simulate a statistic. Can you remind me what is that procedure? We take a sample, okay, one sample, we compute the value of the statistic out of that sample, then repeat this multiple times, okay? Usually thousands of times, okay? In each time, we get a new sample and compute the statistic out of this sample. Now, after we get all the values from these repetitions, what should we do? We plot it, okay? We look at it and make conclusions or decisions based on it, okay? So that's the procedure. We figure out how to generate one value. Of course, this is very detailed. We create an empty array to collect the simulated values. We repeat, get one value, append that value to the array, and at the end, the array will have all the simulated values. And these simulated values, of course, will vary because they are taken from different samples. Each sample will give us a value of the statistic that can be different. And this set of values will constitute what we call empirical distribution. So we talked about empirical distribution before, right? Empirical distribution has all the observed values of the statistic, and with each observed value, the proportion of it. Okay, what we can see as the probability of seeing that value. And this empirical distribution, from what we observe, is a good approximation to the actual probability distribution if the number of repetitions is large enough. Okay, so this is a quick review of what we covered, I think, in the last couple of lectures. Now, today, inshallah, we'll talk about models. Okay, that's a new concept. So what do you mean by a model, especially in data science? So a model is a set of assumptions about the data. So we have data, we have some assumptions about the data. This is what we call the model. And usually the assumptions are about how the data was generated. Okay? In other words, what is the distribution or what is the random process that was used to generate this data? That's what we call a model. Okay, so the model is a set of assumptions about how the data that we have is generated. So in data science, many models involve assumptions that involve randomness. We call these models chance models. So as I said, a model is about how the data was generated or what kind of distribution generated this data, and the distribution, of course, is associated with a random process. Okay? When we talk about probability distribution, we are talking actually about a random process. So there is some chance to get this value over that value over that value. So the question here is, how do we know if the model is good or bad? How do we know if the assumptions that we have about the data are good or bad? Okay, so that's the main question of this session. Given that we have data, we have a model about the data, how can we know that this model is good or bad? Or in other words, how we can assess the goodness or the quality of the model. Okay, so that's the main question that we will discuss in this session, inshallah. So we'll talk about, or we will talk about this assessment of models in the context of an example, and what could be better example than what concerns the world now. What concerns the entire world now? Yes, coronavirus. So that's the example that we will talk about. Okay? Of course, we will not talk about how you protect yourself or all of these things. We'll talk about data science. How can data science answer questions about this phenomenon or this virus? One of the questions, of course, you know that it's the virus spreads now over so many countries. Do you have any idea how many countries were infected already? Any guess? Yes, how many? I mean, maybe 10, 15 or more, like what? Like 100, about 100 countries now. Okay, of course, the numbers vary from a country to another. And by the way, this map was taken yesterday morning because it changes over time. Of course, these numbers change, and even the data set that we will work on change over time. So the data set that I got was yesterday morning. Okay. So one of the questions that data scientists can answer regarding coronavirus is this one. Are infected cases in different countries proportional to their populations? So what is the meaning of this question?
Is the number of the infected people are proportional or related?
Are proportional to the population. Okay, so in other words, okay, we can maybe say it in a more informal way. Is the number in a specific country, the number of infected cases in a specific country, relative to its population? Okay, which means that if the country has a large population, will it get so many infected cases, maybe more than less populated countries or not? So that's the question. Okay, so the question is clear? Okay, time. What we will study in this lecture, and probably will not have time to finish, is how we can answer this question. First, any guesses about the answer? Is that yes or no? This is a yes-no question, right? Do you have any guess? Maybe yes. Maybe yes means also maybe no, right? Okay, maybe yes. What? So all of you yeses? No. Why not? You don't think? Okay, so some of you are saying yes, some of you are saying no. Let's see what data science can tell us. Okay? Type. What is the model here that we want to test? What is the model that we have in mind about the data? Okay, in the context of answering this question. So the question is talking about the numbers of infected cases relative to the populations. Okay, so what is the model that we have in mind here? What is the assumption that we can start with, that we want to test whether it is right or wrong? Yes?
It's proportional to the population.
Yes, so the model is that we assume that infected cases spread more in large proportion, populations. So if a country has large population, then the infected cases will be more. Okay, so which means that the virus will spread more in large populations. Okay, depending on the numbers that we have here. Or in other words, it propagates uniformly according to populations. Okay, so here we start with the word uniformly. Okay, give you a sense of sampling, right? It's like if that model is true, that means that the virus spread randomly over all countries, which will be like, well, remember that the word random in data science and statistics is different from the word random in our daily life. When we say random in daily life, it indicates that we really don't know how it goes, right? How it was done. It's random, right? But in statistics or data science, when we say random, it's not like that. Random means that there is a random process that generated this, okay? Which means that there is a distribution, okay? There is a distribution, probability distribution behind this random process, okay? And the probability distribution here, when we say random, the probability distribution here will be the populations, the distribution of people over the countries, okay? So if that assumption is good, that means that the disease will increase, the infected cases will increase when we have a large population in a country, okay? So that means that if I randomly sampled from the entire world, I will get numbers similar to what the numbers that we have already infected in each country. Okay, is that clear? Okay. So the question now is, how good is that model? How can we test that this model or this assumption is good or bad? And that's what we will do together. So I don't know if you noticed that I uploaded these data sets. So can you please open these, or it's up to you. You can work with me. I will do it online, here, hands-on session with you. You can do it simultaneously, or you can just follow up with me on the board. So the first question: what kind of data sets we need to answer this question? What are the data sets that we need? Number of cases and the population per country. So number of cases per country and the population per country. And this is exactly the two data sets that we have. Okay, so here is the first data set. Of course, it's a big table: country, cases, new cases, and so on. And you see here that this is 10, and we have 87 rows, so we have like maybe 97 countries. Although some of these rows are not countries. Something like Diamond Princess. This is the name of a ship that is in the sea now. There are infected people there, and they cannot belong to any of the countries. Okay, so that will not be accounted here. So which columns we will focus on here? We don't have the population here. Cases, so country and cases here, right? Okay, and the other data set is the world population. So we have the country and the population and other information also. Here the population is in million, of course. Okay. Okay, now what should we do? Join. Okay, so we should join. So this is, so we say Corona, this is the data set, the first data set. Dot join. Join based on which column? Country. And join with population on country also. Okay, if we do that, then we have this table. Which columns we need from this table? Country, cases, and population. So this is, sorry? No, active cases are not the same, I think. active care because some of them might be dead or might be recovered. So cases is the total cases, total infected, and that's what we want. Okay, so we want to get only this column, and that column, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can select 0, we said 0, 1, and 9. Yes, so that's what we want, right? So this is exactly what we want. Let's call that corona with population, CWP. Okay, now we have the table that has the country, population, and cases. What should we do? Take a sample? Okay. Before taking any samples, can we do some plots that might give us some ideas? What kind of plot we can do here? Scatter. Okay, scatter. So we can have a scatter plot between the population and the cases, right? Okay, so we can do that. CWP dot scatter, and which you said population, which I think the second column, column 2, and column 1 is the cases, right? So we get something like that. Is that informative? What are these two? These are like outliers, right? What are these two outliers? So this is an outlier where it has very high population and this one. Very high population and large number of cases. This is China. Okay? This is China, of course. Okay? So that's an outlier. How about this other outlier? So, no, this one is very large population with very few cases. It's almost 0. I don't know if it's 0 or maybe very few. Huh? Any guess? No, this is India. This is India. Surprisingly, it has very few cases so far. Although it has, of course, very high population, very close to China. Okay? Type. What should we do now? How can we focus on this part only? Yeah, remove what? The outliers. Okay, so how can we remove the outliers? How can we get rid of these 2 points? Maybe if we selected only the rows that has population less than 500? Okay, so let's do that. How can we do that? How can we get rid of these rows? How can we select rows? Which function we use to select rows? We select specific rows, but we need a condition, right? Where? So where? So where I need, so population is, I think, column number 2. And what is the condition? Below. Okay. Below what? 500. Okay, now we got rid of China and India. It seems there are still some outliers, but do you see any trend here? Do you see any pattern? Can we answer the question from this plot? Doesn't seem to, right? It's not clear. It's not clear. Okay, if it was like increasing linearly, then we could say yes. Okay, but it's not. That's not very clear. Okay, so maybe this is not the best way to do it. Now let's think about sampling. Let's think about sampling and about the model that we have. How can we say that the cases, the distribution of the cases, so the model, what is the model that we have? The model that we have says that the distribution, we can say it in a different way. We can say that the model or the assumption is the distribution of the cases is similar to the distribution of the population. Right? Right? So the question was saying if the cases is proportional to the population, right? So that means that the distribution of cases over countries is similar to the distribution of the population over countries, right? So if I compare the distribution of cases over countries with the distribution of people, the population over countries, and this comparison, if I found these two distributions are similar, then that might give us an indication that the answer is yes. Right? Okay, now, how can we compute the distribution of these two things? How can I compute the distribution of cases? I have the CWP table, right? Okay, how can I compute the distribution for cases and the distribution for population? How can I convert these numbers into a distribution, a probability distribution? No, the numbers. I don't want to visualize them. I want actually to get like the percentages or the fractions. That's the distribution, right? How can I compute the distribution for cases? Not overpopulation. If I look at only cases, how can I convert this into percentages? How can I say that this 17 is like 10% of? Yes, so we'll divide each value with the total of the cases, right? So let's add one column here that will show us the distribution, the percentages. Okay, so we'll start with CWP. How can we add a column with column? Let's call it percent cases, and we will add the cases column, which is CWP dot column. Which column is that? Number 1. That's easier. Divided by the sum of that column, right? Okay, are you following with me? So if I do that, I will get a new column here, which is percent cases. Now these are fractions. What is the sum of these numbers? 100 if they are percentages, but they are not percentages, they are fractions. So it will be 1. Yes, so it will be 1. Okay, can we do the same for population? We can do the same, right? So we can do the same here. We can say, let's take this. So call that percent population. And this is now column 2. And this is column 2. Right? Now we have 2 new columns. Okay, do you have a question? Okay, so we have 2 new columns here. Okay, now if these 2 columns are similar, so these 2 columns are what? Are the distribution of the cases and the population, right? If the model is true, if the assumption is true, then these 2 distributions should be, of course, they won't be exactly equal, but they will be very similar, right? They should be very similar, right? Right. How can we capture this notion of similarity? Okay, if I have 2 numbers and I want to see how far they are from each other, what should I do? Subtract them, right? Subtract them, right? So maybe if we can subtract these two columns, we can get something useful. Let's see. Let's call the column for the percentage, we'll call it cases. Average of what? Of the values? But we want to compute the distribution. We don't want to compute just one number from here, one number from there. We want to compute difference between the distributions. Let's do this. So this is the cases. Cases is column 1, and let's say, so let's call this cases proportions, and population proportions is CWP dot column 2. Okay, now if I take the difference, if I say cases proportions minus population proportions, something wrong here. So what's wrong here? Cases. So this is, oh, so it should be column 3 and 4. 3 and 4. But that's not the problem. So this is column 3. Okay. Okay, so this is should be updated. So now this is CWP. Now this is CWP. And this is the proportions of the population. Okay, so are you following with me? So these are the two distributions. Okay, if I take now the difference, I will get another array that is the difference for each country, right? Right? So these proportions are the two columns that we had here, right? We had them here. If I can say CWP here, you will see these two columns. Okay? If we take the difference between the two columns, this will give us an array that has the difference for each country. Now, what should we do? Can we get a value that will tell us how far they are? Can we get one value that will tell us how far these two distributions are? Because I'm trying to mimic the idea of computing how far two values are from each other by subtracting them, right? So I started by thinking maybe if we can subtract the two columns, which means that subtracting each corresponding value, that might give us some.
But why the number of percent of cases with percent of population?
Well, that's how we computed it. So these are percentages or fractions. Okay, so let's say that we have 3 countries only. Okay, and the percentages are 10, 30, and 60, the population. When we get a sample, we might get 5, 15, and 80, right? We want to see the difference between these two distributions. So one way, I didn't say that this is the right way, by the way, but one step is to just compute the difference between them. But now the difference will give us an array. Can we convert that into one number? The average of differences, or sum, right? Sum will be similar, right? So if we do the sum of these differences, what should we get? First, before we answer this question, do you see this? This is the difference, right? Do you notice that some of them are positive and some of them are negative? Right? What is the meaning of this? Of course, not the number of cases, the percentage Okay, so the percentage of cases sometimes is bigger than the percentage of the population or the opposite, right? طيب, if I sum all of these numbers, because each column originally the sum of it is 1, right? The sum of it is 1. If one is different from the other, then it has to increase somewhere and decrease in the other, in one country and decrease in the other country, right? With the same value. And if I change the distribution, okay, let's say that I have 10, 20, 70. If I have another distribution that starts with 5 and 20, then the other one have to be 75. So I took 5 from one and I added it to another, so that the sum will be the same. Okay? So if I sum all of these differences, then the positives should cancel out the negatives. Right? Because it's a distribution, right? The sum is 1. Not the number of cases in each country, but the idea here is that if I do the sum of this, let's take the sum of this. Sum of this column, sum of this array. What should you expect? No. The sum of each array, original array, is 1. So sum of this is 1 and sum of this is 1. But the sum of the differences is 0. Okay, so if we try this, did we get 0? This is almost 0, right? This is, if you look at it, it's minus 1.6 times 10 to the power minus 16. It's very long zeros, very long series of zeros. So this is 0 actually. Okay, and this is what we expect. Okay, so the sum of the differences is not what we want. We want something else that we will know, inshallah, in the next lecture. Okay, so we'll have to stop here and we will answer the question, inshallah, in the next lecture. Okay, any questions? Thank you.